Okay, moving on to our next page, and therefore our next section, section 6.3, function operations and composition. We are given two functions, f of x and g of x, and we are first asked about the domains of them individually. So f of x, we've got 3x to the negative first. Well, instead of using our negative exponents, let's think about the fact that that moves it to the denominator. Our 3 stays on top, so we really just have 3 over x. Well, if that's the case, what can we never have in our denominator? 0. So our domain for f of x is that x cannot equal 0. Our domain for g of x, well, g of x is a linear function. What can you plug into a linear function? Whatever you want. So our g of x domain is all real numbers. Now in example B, what is f of 3 plus g of 3? Well, find them separately. F of 3 tells us, and then again, I'm going to go back to, whoops, not that one, but our 3 over x function. So that's our 3 over 3, which tells us it's just 1. So f of 3 is 1. Let's figure out what g of 3 is. G of 3, we've got 3 minus 8. Well, it's going to give us negative 5. So I'm supposed to add those. 1 plus negative 5 gives us a negative 4. And g of x minus f of x. So we want to take our g of x function, which let's say that's x minus 8, and we are going to subtract. Let's go back to our original function, 3x to the negative first. If I could combine something, I should, but I can't, so I won't. And there we have it. Now in example D, f of g of x, so that's telling me I want to take f of x and evaluate it at x minus 8, because that's what g of x is. So that means I'm taking 3 and I'm dividing by x minus 8. If I could simplify further, I should, but I can't, so I won't. Other way around though, g of f of x, that means that I want to take my g function and evaluate it at 3x to the negative first. So that means I'm taking 3x to the negative first and I'm subtracting 8. Again, if I could simplify it, make it look any prettier, it could, but I can't, so I won't. And lastly, for f, what is f of g of 9? Well, we first want to figure out what g of 9 is. So that's going to mean that we are going to take 9 and we're going to subtract 1. Well, going to subtract 8. That leaves us with 1. There we go. So that means that I want to find f of g of 9, which we just said was 1. So I'm finding f of 1. So I'm going to take 3 divided by 1. That gives me 3 for my final answer. Now, same thing for problem number 5, just new functions. So first, what are the domains of these guys? Well, let's start with g of x, because that one's a little bit easier. G of x has a fractional exponent, but the denominator of that exponent is odd. So that means our domain for g of x is going to be all real numbers, because you can take the cubed root of whatever you want. For f of x, though, we have a fractional exponent with an even denominator, which means that's involving a fourth root of x. You can only take even roots of positive numbers and 0. So our domain for that guy, x, has to be greater than or equal to 0. Now, if I want to multiply f of x times g of x, that means that I'm going to take 27x to the 1/4 and multiply by 16x to the 1/3. Well, 27 times 16, that gives me a 432. X to the 1/4 times x to the 1/3, we add our exponents. So that gives me x to the 7/12. Final answer. F of g of x, well, we are going to plug g of x into f. So I want to find f of 16x to the 1/3. So that means I'm taking 27 and taking that 16x to the 1/3 all to the 1/4 power. So remember, if I'm taking an exponent, the power of a product, I have to remember to distribute that. So I'll have 27 times, 16 to the 1/4, that's the fourth root of 16, that's just 2. And then x to the 1/3 times 1/4, because remember we multiply powers when you take a power of a power, and we've got x to the 1/12, So 27 times 2, I get 54x to the 1/12. And lastly, g of f of 1. So let's first find f of 1. F of 1, we get 27 times 1 to the, honestly, whatever power, because 1 to any power is still always going to be 1. So we've got 27 for that guy. then that means I want to take g and evaluate it at that value. G of 27 means we're going to take 16 times 27 to the 1/3. Well, 27 to the 1/3, that's the cubed root of 27, which is 3. 16 times 3 is 48.